All right. So you guys just finished your Forever Endeavor final. You passed up your When You See You Thinks and then your 2017 FRQs. I had you guys working on this 2013 number 2, so if anybody is just joining us, you might want to go ahead and pause this video and try it. This is one where a large majority of BC kids scored low. Maybe not on the entire thing, but definitely on A and maybe on others as well. So I have this in my calculator. The kiddos have been grading it for a little while. I put my 2 functions in. I guess I could zoom in just a little bit. I don't know if that would necessarily help. I guess I could at least make my y-mins not quite as extreme. Kiddos, if you had your graphing calculator in sequential mode, it would graph the first one, r equals 3. It's a circle, goes normal, 0 to 360. Then you have the second one as well. Now, we're trying to find the area inside both of them. True? Okay, so as we do the area inside both of them, as you guys are looking at this picture, what do I need to consider as I'm doing the area? And this one actually wasn't even as tricky as another one that I've seen, but this was tricky. What do you have to consider? They told me, what about these 2 curves? What's my intersections?
Pi over 6 and 5 pi over 6.
Good, pi over 6 and 5 pi over 6. Why can't I just use that as the bounds for both? You have to think about going from the pole out, right? And that's going to be to this one curve, which is not the r equals 3, but the other one, in between these 2 bounds, in between pi over 6 and 5 pi over 6. That one would be okay. And that's to the second one, or r2, or that's to your second curve, not the r equals 3 one. But then what do I have to consider for the other one? The circle. Very different bounds, right? What bounds did you guys choose to do? You went from 0 to pi over 6. Okay, so then Kyle went from 0 to pi over 6 and got that little bit. He could have doubled that to get over there. And then what else could you do? You could see this as a semicircle if you wanted. You could do 1/2 pi 3 squared, right? So there are a few different ways of doing it. You could have also done the bounds of 5 pi over 6 to 2 pi. No. 5 pi over 6 to 2 pi plus pi over 6. That would technically be that region. But you had to split up the bounds. Now, in the answer key, did they show that? Not necessarily. There are different ways of getting this 6 pi. They made it look all nice and easy. Right? Probably the easiest way would have been, as far as having everything, probably would have been the 5 pi over 6 to 2 pi plus pi over 6. That'd be 13 pi over 6, right? Of your 3 squared d theta. That way you could have just plugged it in your calculator. So starting at 5 pi over 6 and going all the way around to 2 pi plus pi over 6. Then you could have added the other area that you guys see right there displayed. How'd you guys do on B and C? Yeah. But you did state it.
Yes, I did say x equals r cosine. I didn't plug it in.
So what? So you never wrote that what r cosine theta was?
Because I wrote that.
Did you? Oh, you wrote this one.
And then I said,
Totally fine. Totally fine. So if you wrote that, that could be your x of theta, and then you applied it. That's okay. You didn't necessarily have to go from there to there. That's okay. That's okay. You guys realized for your position vector, you had to think of what is x of theta, what's y of theta, using your r cosine theta and r sine theta, right? And then solve. I do have another few FRQs up here, so if you guys do want to check out this video at a later time, and then go ahead and pause it and try. If we did have tons and tons of time, I would probably go ahead and let me screen shade it. I would probably have you guys do question 4. Which has to do with a differential equation that has a minus. Does anybody know why this one is super nasty and why kids would have hated it? This was Danny Regan's year. Corey, go ahead. You can't integrate it. And I've made a very, very, very specific way of, or point of emphasizing that to you guys throughout the year and CalcAB as well. Because what do you think most of the kids thought of as soon as they saw this?
Integrate.
They thought you need to separate and integrate. And so they tried and tried and tried and tried and tried and tried and tried, but it was impossible. But here, does it say find y equals f of x? No. It says let y equal f of x be the particular. Keep reading. There's your initial condition, true, but what's it say? All it's asking for is relative min, relative max, or neither. Well, if you just found the second derivative, what test are you going to be doing for the relative min or max or neither? The second derivative test. And what do you need in your explanation to prove what it is from the second derivative test? That's not all. What's the first thing you need? Critical number. You need dy dx to equal 0 first. So you would need to plug the point into dy dx. It does equal 0. That's first. And then second, now the concavity. So as long as you have a critical number and the concavity is positive or negative, you can make that justification. Oh, so, sorry, I didn't remember what the answer was. Usually it's 0. It's neither, because it's not a critical number. So you wouldn't have even gone to the second derivative test. Gnarly. So not only did most people try to separate, at least in my class, most people tried to separate and integrate because we had worked on that so much. They saw that like, yay. But also, yeah, it's not a critical number because it'd be 4 minus 3 is 1. Good call. But guess what other part they hated? D. I'll show you the answer key to that one in just a second. I would have also had you guys look at this one. Question number 6. Not that it's impossible, but it definitely, you're like, the radius of convergence, and they give it to you in a summation form. They're asking for the first 3 non-zero terms, the derivative, the general term, and then they say find the function f prime. You have to think of who's f. Well, the Taylor series for f prime. And anyway, it's definitely a very interesting one. You have that whole radius of convergence down here that you're supposed to play around with. There's a lot going on in that FRQ. There's also this one with the baby bird. It's technically a CalcAB one. But it was a little bit mean in letter B when they're like, hey, use the second derivative to explain why that's impossible. You're like, oh, great, this will be fun. Not that it's bad and not that it was too ridiculous. And hopefully the separation, they do ask you to use separation of variables to solve. But guys, how would you have solved this guy? Multiply by dt, divide by 100 minus b. You would have done u sub, gone to ln, but hold on with your u sub. Wouldn't there have been a negative? Okay, careful. And then we're back at this polar area one, which was one of the gnarly ones. There's definitely a gnarlier one where technically the bounds are totally different. I thought I had found it, but I didn't. These bounds were different, but these angles, the pi over 6 and the 5 pi over 6, were truly where these hit, which made it a little bit nicer. Guys, I'm going to go ahead right now, come over to those 4 that I just showed in case you check out the video later. I'm showing the answer key so that you guys could come back and grade it. I'm showing the answer key. I'm showing the answer key. Now, how did I find these FRQs? Do you have a lot of stuff you can play with? Yeah. Yes. Do you have a lot of stuff in your folder that you could play with? Yes. Do you have Khan Academy that has like all these practice questions for AB and BC and a live study session from last year? Yes. What is due on Monday? All the bonus. And if you have not yet started a bonus exam, what would I tell or where would I tell you to start? The emailed last year mock AP. Sound good? All right, cool kids. I'll see you later. Sorry, Jason. Bye, guys.